Hey guys, welcome back to KIS Module 7.4. Last lesson we finished going through the chemical differences and physical differences between primary, secondary and tertiary alcohols. Since now, instead of looking at a whole homologous group called the alcohols, for example, we're going further and probing deeper into this concept of chemical and physical differences, and we went through the differences between different types of alcohols such as primary, secondary and tertiary. This lesson we're going to be going through some reactions of alcohols, which I believe is basically what all of 7.4 is about, alcohols. So this lesson we're going to be going through combustion, and I also believe we're going to be going through dehydration, and if we have time, also substitution reactions, okay? So going through combustion, we know just probably from general knowledge, you should know that alcohols are actually very flammable. What does that mean? They combust very, very easily. So we can kind of start off with a general statement that says primary, secondary, and tertiary alcohols can readily combust in the presence of oxygen to form carbon dioxide and water, as they're flammable with low ignition temperature. So that's basically, we should kind of know that from general knowledge. If you've ever seen action movies or whatever, you know they can sometimes burn alcohols. Methylated spirits have a lot of alcohol. Hand sanitizer, alcohol. So those kind of things are very, very flammable. So let's write a general statement regarding the combustibility of alcohols. So primary, instead of writing primary, secondary and tertiary, we can use this notation, which means primary, secondary and tertiary alcohols. However, it's not actually stated in the syllabus. I think it should be fine to use, the syllabus doesn't say it, so I did avoid it, but I think if you do write it, there's going to be no issues. So you have primary, secondary, and tertiary alcohols can, let's put a little distinction line here, can readily combust in the presence of oxygen. I'm not going to write to form carbon dioxide and water because we're going to go through that later. Combust in the presence of oxygen, as they are flammable, and have a low ignition temperature. If you don't know what ignition temperature is, it's basically the lowest temperature at which an alcohol can catch a flame, basically. I don't know the exact numbers, but I just know that they're very, very low ignition temperatures and they can readily combust. If you think about it, we use, well, in most of our cars, if you have a sports car or a diesel car, I don't know, but if you use regular petrol, you use E10. What does E10 mean? It means the petrol, which is actually octane, is made up of 90% octane and 10% ethanol. Okay, we know that ethanol is an alcohol, and we know that it combusts easily because a car can run on ethanol, and just like we know that cars have internal combustion engines until so far, except a few electric vehicles, but they do combust ethanol. So ethanol is very combustible, just like many other alcohols. So I thought I would just tell you that in case you didn't know. So let's actually go through what combustion is. Combustion is actually a form of extreme oxidation. Let's write that down. Combustion is a form of extreme oxidation. We spoke about oxidation a little bit before, but we didn't really go through in detail. We're going to go through oxidation in a lot more detail, but you have to know that combustion is actually a form of oxidation, where basically all the chemical bonds of the alcohol and the oxygen are broken, so that all three forms of alcohols are going to readily combust. Let's write that down. So it's a form of extreme oxidation. All chemical bonds of oxygen and carbon are broken. So it's basically a kind of extreme case of oxidation. Alright, so now let's actually go through what happens in an oxidation reaction. You should have learned this by now in kind of junior science, but if you didn't, we're going to go through it very quickly. In a plentiful supply of oxygen, alkanols or alcohols are going to undergo complete combustion. So, in excess oxygen, we have complete combustion. Complete combustion. What does this mean? What happens in complete combustion? We only have products are CO2 and water only. So in complete combustion, where there is an excess of oxygen, we only get carbon dioxide and water. However, in a restricted supply of oxygen, we get incomplete combustion. Okay, so what happens when there's incomplete combustion? The alcohol is actually going to burn incompletely, as you probably would have guessed, to form a mixture which contains different amounts of carbon dioxide, carbon monoxide, carbon, which is soot, and water. Okay, the longer the hydrocarbon chain, the more likely incomplete combustion will occur because it's harder to completely oxidize the alcohol. So let's write all of this down. Products are a mix of CO2, CO, C, and H2O. So it's a mix of that. A good note here is the longer the carbon chain, the more likely incomplete combustion will occur. There we go. As we said before, why is it like that? Because it's actually harder to completely oxidize or to undergo extreme oxidation. Now, let's go through equations of a complete combustion and an incomplete combustion. So with a complete combustion, for example, let's go with ethanol. So ethanol is C2H5OH. So here we have ethanol, and we're burning it in oxygen. Actually, ethanol is a liquid, so we should have our states. And we're going to have carbon dioxide formed and water, since this is complete combustion. I'm going to go ahead and balance this really quickly. So we're going to have a 3, 2, and 3. Okay, so now that we've balanced the equation, we can see that with an excess of oxygen, this works very well. We have an alcohol, oxygen gas, to make carbon dioxide and water. So we have an alcohol, oxygen gas, or just oxygen, carbon dioxide, and water. So that is our complete combustion. Complete. Okay. What if we go through incomplete combustion? Let's do incomplete. Let's say we're doing the same thing. So we're going to be doing ethanol and oxygen. So C2H5OH plus O2. What is it going to give us now? Let's say that we don't have carbon, just soot in this reaction, because it makes it a little bit more difficult. So the majority of incomplete combustions are actually going to have the majority to be carbon monoxide. So let's put carbon monoxide and water. Okay, now let's balance this equation. 2, 2, and 3. So as you can see, when we have a drop in the mole ratio of oxygen, we actually get incomplete combustion, and we're going to produce carbon monoxide. So here we have the alcohol. Here we have the oxygen gas, oxygen. Here we have carbon monoxide, water. Carbon monoxide is actually very, very toxic. And I'm going to give you a little story that I heard yesterday or the day before. Not when you're going to be watching this, but when I recorded this video on the 12th of February. Actually, I'm going to say very quickly, we've had very, very significant rain here. So there's a power outage in a lot of houses, okay? A young man wakes up, he's got a family and 3 kids. He's got a wife and 3 kids. He wants to have a hot shower in the morning. So he goes downstairs to his garage and turns on an electric generator. And how does it make electricity? It obviously burns some type of hydrocarbon or petrol or some type of mixture to produce that electricity. So what he does, he turns it on in his garage, and he leaves it on for about 40 minutes so he can have a hot shower, so his electric water heater can work. So he comes out of the shower, he turns off the electric thing, and then he leaves off to work. And his wife and his kids are still sleeping. About 15 minutes later, the fire department comes in. The fire alarm went off. I'm not sure why the fire alarm went off. It might have been, I don't know, just out of luck. The fire department comes, and they find the 3 kids and the mother unconscious. Why are they unconscious? In those 40 minutes, he ran the generator, which is meant to be run outside for your information. He started having incomplete combustion. Why is that? Because it used up all the oxygen in the garage, okay? So what does this mean for us? It kept having incomplete combustion and kept releasing carbon monoxide. The carbon monoxide actually went through the whole house and knocked the wife and the 3 kids unconscious because they were already sleeping, so they had no idea. Maybe 5 more minutes and they all would have died. So that's just how dangerous carbon monoxide is, and I'm just gonna warn you here, if you ever do an experiment like this at school, make sure you're very well ventilated, and if you ever in your life use a generator, make sure you keep it outside just for your safety and the safety of anyone around you. So that was an interesting story about combustion. Now let's move on to dehydration of alcohols. We kind of went through dehydration before. We didn't go through it directly, but we went through the hydration of alcohols. Dehydration is basically the opposite. When we went through hydration, we said this process was reversible. So let's get straight to the point with dehydration. So when alcohols are dehydrated, alkenes are formed. When we hydrated alkenes, we formed alkanols or alcohols. Okay. This reaction actually needs a catalyst as well, which is concentrated phosphoric or sulfuric acid. Why is that so? Because they are dehydrating agents. We're going to go through that as soon as I write out the equation so you can kind of understand. So let's start with this. Opposite of hydration. That's kind of given because dehydration, opposite of hydration. Okay. And then we say when alcohols are dehydrated, alkenes are formed. Okay, awesome. Requires a catalyst. The catalyst is usually concentrated H2SO4 or concentrated H3PO4. Okay, and they both have to be 170 degrees Celsius, so it actually needs to be quite hot. So let's write out the equation. C2H5OH. I love my ethanol, so we're just going to use ethanol again here, and it's a liquid. Make sure we put our catalysts. We have concentrated I like H2SO4 because it's very common. Okay, and then with dehydration, we said with hydration we add water. With dehydration, obviously we're going to be releasing water. So we're going to have our ethene because we're dehydrating an ethanol, and we're going to get our water molecule. Okay, so that's basically our dehydration. Let me write down a word equation. We have, let's use another color. We have our alcohol okay, and it goes to an alkene and water. Awesome. So as I said before, this reaction is reversible, so we can hydrate the alkene or we can hydrate the ethene to produce an alcohol. But instead, the only difference is, if you remember, we use dilute H2SO4 when we're hydrating and concentrated H2SO4 when we're dehydrating. Concentrated H2SO4, so sulfuric acid, is actually a dehydrating agent. And what does that mean? It absorbs water very quickly, so it brings it to itself. So when we put it there as a catalyst, we usually just put a few drops, or like we would put a few drops when we're hydrating. When we're dehydrating, we put an excess of concentrated sulfuric acid. And why do we put excess? Because it's a very, very good dehydrating agent and it'll suck up all the water. So then we're going to get an alkene at the end. We don't have time to go through substitution this video, so we're going to go through it next video. I hope you've understood everything once again. The combustion of alcohols is something that's very common around us, so if you still have any questions, feel free to ask me, and it's a good question to be asked in the HSC, so please make sure you understand everything. Dehydration is basically the opposite of hydration, so if you have any questions on dehydration, try and go back and listen to the video on hydration. That might help you a little bit. However, if you're still stuck, obviously ask me, and I will see you guys in the next video. Thank you for watching.